Alright, let's look at example 2a. We're required to evaluate the exact value of the given definite integral. So how do we go about integrating? So first thing first, we notice that there's a fraction 5 divided by 1 minus 4x involved. So do a quick check, you realize that the denominator is of degree 1 and the numerator is of degree 0. So it seems like we can actually think along the line whereby integrating this fraction gives you the ln of this plus c. Why? Because of the fact that this fx here has 1 degree higher than that of the numerator f prime of x. Now, if I see my fx as 1 minus 4x, then my f prime x has to be negative 4. So the question itself, there's a 5. So what we can do is do some balancing. We expect a negative 4 here. So of course we will multiply by 5 divided by negative 4 outside. So once you are ready, there shouldn't be any issue integrating this particular integral. So what we get now is ln of modulus 1 minus 4x, and all we need to do is to bring in 0 and negative 2. In other words, this ln 1 comes from 1 minus 4 times 0, and this ln 9 here comes from ln of 1 minus 4 of negative 2. And eventually you will get this as an answer, simplifying 5 over 2 ln 3. Alright, let us look at the next example, example 2b. We are required to evaluate this definite integral. Okay, how do we go about doing? We look at this fraction and we start to think, is there any formula that we have learned it before, or any formula given in the MF15? If you observe carefully, it looks like we can make use of this. This is given in your MF15. Right, I need to emphasize that this formula is only applicable for x squared of coefficient 1. How do you make use of this formula to help us evaluate this definite integral? So first thing first, I need a 1 on top here. So what I can do now is to bring the 2 out. And at the same time, since I know it has to be in the form of square root of a squared minus x squared, I'll write it in the form of a squared minus x squared. Now the next step should be very straightforward. We know there's a 2 outside, and we already know what is the antiderivative of 1 over square root of 2 squared minus x squared. This gives us a sine inverse x over 2. Root 3, negative root 3. So the remaining should be very simple. Now I just need to put in my square root 3 and my negative square root 3. So now I have 2 times sine inverse of square root 3 over 2 minus sine inverse negative square root 3 over 2. So using our GC, you will be able to evaluate the value of sine inverse root 3 over 2 and at the same time sine inverse negative square root 3 over 2. And finally, this is the answer, 4 pi over 3. Right, next example, example 2c. We are required to integrate from 5 to 10 of secant square x dx. And based on what you have learned in basic integration technique under the section of integration by standard form, you should be able to understand that integrating secant square x gives us tangent x. So in other words, now I'll have this, which gives us tangent tan minus tangent that of 5. Done. Okay, this question requires us to actually write our answer in exact form. So this will be our final answer.